Hey everyone, we're going to look at number 1 in section 3.6, which is to find the equation of the tangent line to this function y equals 7 times tangent of x. And we're going to find that equation of the tangent line when x is 5 pi over 4, so at that location. So two things we need for the tangent line is the slope and the point. The slope comes from the calculus, which means we need to find the derivative, right? The derivative of this function. And to do that, you need to find the derivative of tangent x, because when we find the derivative of 7 tangent x, 7 is a constant multiple, and we just need to know what the derivative of tangent x is. Well, derivative of tangent x is secant squared x. Okay, now I derived that in the lecture video. You do need to know the derivatives of all 6 trig functions, but if you can get the derivative of sine and cosine down, then you can easily find the derivative of tangent, or remind yourself of it, because you can write tangent x, remember, as sine x divided by cosine of x, right, from our handy dandy ratio identity. And then you can use the quotient rule on this to find the derivative for tangent x. You do have to do a little bit of rewriting, and I show you how to do that, but I would practice doing that in case you forget. I mean, if you want to memorize the derivatives of the 6 trig functions, that's great too, but just make sure that you are able to find that. Remember, when we say secant squared x, that means secant of x quantity squared. Okay, so that's the derivative. So the slope will be the derivative evaluated at 5 pi over 4. So I replace x with 5 pi over 4. And I'm looking therefore at 7 times the quantity secant of 5 pi over 4 squared. What is secant of 5 pi over 4? Well, it's negative the square root of 2. How do I know that? Secant of 5 pi over 4 is 1 over cosine of 5 pi over 4. And cosine of 5 pi over 4 is negative 1 divided by square root of 2. I can write it in its rationalized form of negative square root of 2 over 2. And that's what you get if you use the unit circle, right? The value of 5 pi over 4, remember, is the x coordinate negative square root of 2 over 2. But it is equal to negative 1 divided by square root of 2, which, remember, this is secant, so it's 1 over cosine. So 1 divided by this, just the reciprocal of that, is negative root 2. If you had the negative square root of 2 over 2, by the way, then the reciprocal would be negative 2 divided by root 2. And what is that equal to? Well, if you multiply top and bottom by the root 2, which is equal to 1, up top you get 2 times root 2. Root 2 times root 2 is 2, and 2 divided by 2 is 1, and we just get square root of 2. So either way, you're going to get and of course it's negative because of the negative sign here. So I mean, this would be negative, negative, negative. Either way, you get negative root 2. Okay, that's inside here. Secant of 5 pi over 4 is negative root 2. But then I'm going to square negative root 2. When I square negative root 2, I get positive 2. So my slope m is 7 times that 2, or 14. That's the slope. Okay, and then to find the actual point on the function, I'm just going to call the function f of x, let y be f of x. I want the point 5 pi over 4, comma, f of 5 pi over 4. What is f of 5 pi over 4? I replace x with 5 pi over 4. I get 7 tangent of 5 pi over 4. And tangent of 5 pi over 4 is 1. Remember, from the unit circle, we know at 5 pi over 4, sine and cosine are equal. And so negative divided by negative is a positive. I get positive 1 for tangent, because tangent is sine divided by cosine. So 7 times 1 is 7. That's the point, the y coordinate of the point. So now I'm ready to plug it in to our point slope form. Y minus y1, this is the y1, which is 7. M, the slope, is 14. X minus x1, and the x coordinate is 5 pi over 4. And so if we solve for y, I can distribute this 14 through 14x. 14 divided by 4, 14 fourths is 7 halves. 7 times 5, 35 halves, 35 pi over 2. So 14 times 5 pi over 4 is 35 pi over 2. Add 7 to both sides, and I can just write it that way. Now, this is fine, I think, for achieve. If you wanted to, you can combine this as one fraction, because you would need a common denominator to do that, which is 2. 7 is 14 halves, and this is the actual constant there, but this is fine. and that's good enough. Hopefully this makes sense. You get some weird answers sometimes when you're looking at equations of tangent lines involving, at functions involving trig functions, because, we get these weird multiples of pi and such, and root 2, root 3, you remember, in those things. So at any rate, hopefully this is helpful.